All right. First of all, to do this right, I'm going to need some assistance from some people. So could you help me, young lady? First of all, I'm going to need you to come up here, please. I need a lot of help. I am getting older. All right. So could you please introduce yourself? What's your name?
Soily.
What is it again?
Soily.
Ooh, that's a pretty name. Now, hold on. Would you mind coming up here and standing right up here for a moment? All right. Let me help you up. Go ahead and stand up on their stage. All right. Now, let me ask you this. Is it true that you have pink pants on and a blue shirt? You have pink pants,
Yes.
but you have a blue shirt on?
Yes.
This is blue? Oh, that's blue. Okay. Is it true that you have now red shoes?
No.
Well, hold on now. But is my statement, I'm partially right? Like you got pink pants on, you got the blue shirt. But if I said you had red shoes, am I correct or am I wrong?
You're wrong.
Even if it's only a little wrong?
Yes.
You are good. Thank you. Give her a hand. Lance, can we switch to the other one? Well, and that's what we're going to look at tonight, is because many of the theories we have, and I'm going to need a lot of help from our younger audience members because I am getting older every day. And so we're going to explore, what does it mean that we have science and people who believe in science and study science, and the scientists say one thing, and then we go to youth group in Sunday school in church, and it seems like they're saying something different. And so how do we know it's the truth and what's right? And just like my young assistant said, if I say one thing that's true and a second thing that's true, but I get part of it wrong, well, then I'm just wrong. So we're going to look at revealing the secrets of the solar system, because as the pastor started out with, he told us that the heavens declare the glory of the Lord, which means that I'm not going to shy away from science. I'm going to grasp it with both hands and jump tight. Let's start with the sun. All right. The sun is the biggest, most massive object in our solar system. What is it?
It's another sun.
That's another sun. This one's our sun. In fact, it's our star. All right. There is one star. This one is the picture of our sun, our star. It's called Sol. Now, some of the things you need to know is it's the most massive thing. If you put all the planets could fit into the sun. In fact, we'd have a lot of leftover room. It's the most massive thing in our solar system. There's over 1 million Earths could fit inside the sun. All right. It's composed of mostly hydrogen and helium. However, that's going to be important. I want you to remember that. It's composed of what? Hydrogen and helium. All right. So I'm going to throw a lot of science at you, because this is where people try to impinge upon our faith, and the science actually defies evolution. All right. So here's some things about the sun. Over 1 million Earths could fit inside it. 99.8% of all the mass of the entire solar system is in the sun. And this is what NASA, if you go to Kennedy Space Center today or tomorrow, and you went there, you would see in the kids' space place, there is a graphic that tells kids, you guys, how the solar system is supposed to have formed. And they say, well, a long time ago, there was all this dust clouds. And then all of a sudden, the dust clouds started contracting, getting smaller and tighter together. And it formed an accretion disk and it flattened out. Now, hold on, though. I'm going to need some help here. What's your name, my dear?
I'm good.
You're good. What's your name?
Maria.
Maria. What's your favorite candle?
Candle?
Your favorite scent or candle?
I don't have one.
None? I bet mom does. What does mom like to put on? Ask her. Okay. What's mom's favorite scent? Like a potpourri. Okay. I'm going to take that one. If I put a candle here in the middle of this table, right? It would not take long for all of a sudden this table would be smelling it. And that table would be smelling. They might even be getting a headache from it because all of a sudden it's so strong. And soon it would go back there and back there. And after a while, it might be faint, but everywhere in this room would start to smell a little bit of the candle. That's how gases work. So evolutionists have actually admitted that there's a bit of a problem. The first problem is that there are these gas clouds that gas likes to spread out. It doesn't like to contract in. All right. There is actually a paradox of gas stability. That's actually the name of it. Paradox of gas stability says that gas likes to go out and not in. And to make this work, for evolution to be true in our solar system, they'd have to get rid of the gas laws. That's number one. But hold on, we're not done, because remember what she told me. If even one part is not true, it's wrong. And we're going to go through the sun all the way to through all the planets and show you an example of each one. So we're not just going to get one. All right. Next, the sun. Oh, hold on. Ready? Now, how many of you like to ice skate? Do I have any young people that like to skate? You like to skate? Do you skate well? Excellent. I need you then. Come quickly. Come quickly. I have another helper. This is amazing. I need a skater, because only a skater could understand this one. Come right up here, my dear. All right. And what is your name?
Julia.
Julia. Okay. Have you ever done a spin on the ice?
No.
Have you ever seen someone spin on the ice?
Thousands of times.
What do they look like? Now, don't fall, but show me what they look like. Spinning on the ice. All right. Okay. Now, hold on now. Let me ask you this question. When you've seen thousands of them, do they have their arms out or do they have their arms in?
They have them in.
You are brilliant. Thank you so much. High five. All right. Thank you so much, Julie. May I help you down? Excellent. They hold their arms in. Why? When things start to rotate, ready? Just like a skater on the ice pulls the arms in, the sun, if it was really going to start from a nebulous cloud to go in and in and in and in and got smaller and smaller and smaller and was before it could combust, it would have to pull in so tight, like a skater puts their arms in, and it would go really, really fast. In fact, they estimate that for the sun to have formed that way, that it had to go around. Well, now, I need someone. Oh, I'm going to need this person right here. Oh, yes, come quickly. I need you to show them, because some of these people haven't been in school in a very long time. I know that's for a fact. So I want you to show them the difference between rotate and revolve. So we're going to start with rotate. Can you please turn for me? What's your name first?
Soraya.
Soraya. Could you please turn all the way around? Now, this is called rotation. Okay, can you say rotation? Excellent. Now, revolution is something different. Soraya is going to show us revolution. Soraya, would you please go around the podium? This is called revolution. All right, go all the way around. You got to go all the way around at least once. That's a good revolution. Now, can you show rotation again? This is rotation. Thank you so much, Soraya. All right. Now, for the sun to actually form by evolution, just like that skater, the sun, all that dust cloud, it would have flattened out. It would start rotating as fast as it could, like a skater with its arms in. And it would be rotating about once every 10 hours or even less, even faster. However, that's not what our evidence shows us. In fact, the evidence is that our sun is not going. Go to the next slide then. There we go. Our sun actually rotates once every 27 days. It didn't go faster. It actually couldn't have actually become a lit up fusion ball star. When we think of fusion, a fusion explosion, the way all the energy is created by our sun, it actually couldn't happen that way unless it was much faster. But that's not what our evidence shows us. All right, next slide, please. All right, so let's even talk about some heat, because the heat is perfect. All right, the surface of the sun is 5,500. She's like, oh my goodness, she's going to give us all these details. Yes, I am. Why? Because these details are what gives us our evidence. The surface is 5,500 degrees Celsius. The core is over 15 million degrees. Now, evolutionists say that your star is over 4.5 billion years old. That's a long time. However, the way stars work, this is pretty cool. Ready? The way stars work is hydrogen gets turned into that other stuff. What was that other stuff? Hydrogen and, oh, you are smart. Hydrogen and helium. Hydrogen fuses to make helium. If you went back 4.5 billion years ago, the way that the hydrogen switches over to the helium, the sun's output in its early years, this is 4.5 billion years ago, ready? Would have been 25 to 30% lower than today. In other words, Earth, to give it in perspective, Venus would have a nice climate. and Earth's climate would be 2 degrees below freezing everywhere on the planet as an average temperature. There is no way life could come about by chance if it was below freezing over the entire Earth as an average. Not possible. The oceans would have been frozen. There was no way life could come about. So another, just one other detail about how it's not possible that evolution happened just from our sun. We've got its temperature, we've got its rotation. Hold on, there's more. Next slide. All right. On top of that, not only would it have been colder, the sun would be 40% brighter today than 4.5 billion years ago. The sun also would have grown 25%. The sun actually gets bigger over time. So it would have been 25% bigger now than it was back then. In other words, it couldn't give not only the heat, the light, the perfect amount of radiation. In fact, do you know what they call our planet? The Goldilocks planet. Now, hold on. Who knows who Goldilocks is? I need help. All right. Yes, ma'am. I need to know who Goldilocks is so they can remember. I don't know if they all remember this story, but tell me about Goldilocks.
Goldilocks was a girl. She walked into a bear's house. She ate their food and she was like, okay, this one's too cold. This one's too hot. This one is just right. All right,
stop there. Cold, too hot, and then just right. Oh, remember that. Go ahead, keep going.
Then there was a chair. She broke one. And the other one was too big, one was too small, and she broke one.
Don't forget that either. That's actually important too. Anything else?
One bed was too fluffy, one bed was too hard, and the last bed was just right.
Now you said the first one, it was too hot and it was too cold, right? Did you know if our sun was any closer to our Earth, that we could not grow food? I don't know. You got to stay up here. You're good. You're good. You're okay. I need you. All right. So we couldn't be any closer to our sun. It would be too hot on our planet for not only for radiation, but for sun, for heat, too far away. If we were out closer to Mars, it'd be too cold. Hold on. What was the other thing? So it's hot, cold. What else?
The chairs.
Too hard, right? Too hard. Okay. So let's talk about this amount of radiation. All right. So does your mom ever make you put on sunscreen? When do you have to put on sunscreen?
When we go to the beach or the pool.
It's a good mom. Okay. Any more sunshine, any more radiation than we get now, we would actually burn up. Any less radiation, and we would not have the radiation we need. We actually need a small amount, which is exactly what we get. You are awesome. Thank you. Okay. But there's another way. All right. If it's not possible, we just looked at 3 different ways. It's not possible that the sun happened by chance. So the other way has to be, the only other option is that in God made 2 great lights, the greater light to rule the day and the lesser light to rule the night. And you know what else is great? At the end, I'm going to remind you, there's actually one more little piece to that verse. Remind me, because I'm going to show you that at the end. All right. There is a magnetic field. So you have magnetic field to planets, but also to the sun. Our star has just the right magnetic field for our planet. What star that's too big, we would roast alive. A star too small, we would never get enough light. We have just ready, even Goldilocks type of star. Coronal mass ejections. If our star was huge or even just 20% bigger, those pieces, have you ever heard of those? Now, some of you might remember that TVs didn't hang on the wall. I remember when TVs did not hang on a wall. Some of you are going, oh my goodness, we did not have TVs on our phones. We did not have iPads, and we did not have TVs that were this big. All right. So she's like, I remember this TV. Okay. Our TVs were giant boxes. They were giant boxes. And every once in a while, it doesn't matter what you did, you could turn the knob, you could hold the little antenna, you could put the cellophane, the aluminum foil over. It didn't work. For some reason, it just went staticky and it didn't work. And no, there was no Netflix. Okay. What was there instead was there was something coming from our star, some sort of either coronal mass ejection. We call them, maybe sometimes you'll hear sunspots, solar flares, all right, solar mass ejections. Our star is actually perfect. It never sends out one too big. Other stars do. Other stars sends out ones that could reach all the way out to Jupiter and would fry everything in between. Our star is considered pretty mild. a Goldilocks star. On top of that, our planet was created perfect to even work with our star. We have an amazing magnetic field. Now, this is pretty interesting. Ready? If the solar system came about by chance, if it was true that evolution was true, if it was, wouldn't you expect all the planets to have the same type of magnetic field? That makes sense, right? If they all are flung off from a dust cloud, they all should have about the same magnetic field. It would be a little awkward for them to play hopscotch. Now, who knows what hopscotch is? You know what hopscotch is? Come here. Okay, now you're gonna have to come up here for this one because hopscotch is a little harder to play. Ready? There you go. So you're gonna go ahead and do the first one, but stop each one. Ready? Go ahead and hop. All right, Mercury has a magnetic field. Next. Venus has only induced, not a regular magnetic field. Again. Earth, great magnetic field. Go. Mars, no magnetic field. Go. Jupiter, yes, has a magnetic field. Nope. Saturn, small magnetic field. Next. Uranus, big magnetic field. All right, and thank you, sir. It was amazing. Thank you so much. Thank you so much. All right. Why isn't that magnetic fields are not identical? Well, that's not the only thing that's not identical. In fact, it almost as if someone designed it with a great sense of humor. We can actually see examples of this magnetic field and how it interacts with our atmosphere in the aurora borealis. That every time, has anyone seen it here? I have yet to see it yet, but has anyone seen it? Oh, okay, our pastor in the back has. Absolutely wonderful. I have yet to see it, but I look forward to this magnetic field. However, we have a little bit of an issue, and we're going to see it again when we hit Neptune. A magnetic field decays over time. As a planet cools and slows down, the magnetic field decays. Okay, well, that's good. We're fine for right now. However, a magnetic field that would go thousands of years, good shape. Million years, probably still good shape. Ready? Billions of years, it would have disappeared. And we're going to actually see that. All right. It's just some pictures of our star, how it goes through cycles. By the way, remember I said that there was all sorts of styles of stars? Our star is actually a pretty mild one. It's in the middle. However, there are really, really big stars, ginormous stars. We've got, I want to say Antares, Betelgeuse. I don't think that one's up there. You've got Deneb is the second blue one here. Rigel's the third blue one. And all the way, you see at the very, very, very end, there's a tiny little one with a little tiny blue pixel. The blue pixel is actually too big. That's our star. Our star is pretty small, but actually it's a midline sequence star. All right, now let's actually jump to some planets because there's a whole bunch of planets. All right, Mercury, 1974, great year I was born. 1974, Mercury, a rocket is launched, sends out a probe. What does a probe do? What does a satellite or a probe do? I have a feeling you know what a satellite or a probe does. What does a satellite do?
I don't know.
No idea. Come on, what's a satellite do? Huh? Good. You're good too. All right, who knows? What's a satellite do? All right, you ready to help me?
It orbits around the planet or a moon, and it kind of like looks at it.
That's right. It goes around. Thank you. Yes, absolutely. Goes around a moon or a planet and looks at it, takes pictures, sometimes does readings on the planet. Well, in 1974, our first satellite went to Mercury, and they came there saying, you know what, because evolution is true, it's not going to have any magnetic sphere whatsoever. It is just a rock. It's so close to the sun, it's a rock. It's just going to be a dead, lifeless, cratered rock. And they got there, and all of a sudden they were shocked. Mercury has a magnetosphere. Then they had to explain it. Well, I don't understand. Why does Mercury have a magnetosphere? I know. All of a sudden, something, now I'm going to get all the kids to help me on this one, ready? Because you're going to learn this line now. You got to learn the line. Ready? They believe something big hit it. Can you say that?
They believe something big hit it.
So something big hit it. Say it.
Something big hit it.
Excellent, because you're going to need to say that again. All right. They believe that Mercury was once much, much bigger. And then therefore something Excellent. Something big hit it and knocked out off its outer shell. Next slide. It's not working. When it knocked out its outer shell, they expected it to bleed. Now, hold on. Now, what are you seeing here? I'm seeing someone here is very surprised at this. Why is this so surprising? Because it's a cartoon. What does it look like on one side? Do you think what does it look like on the bottom side? Looks hot. All right, ready? 800 degrees hot. I know you guys are Floridians, but hello, 800 degrees is a whole new thing. Okay, what about the other side going this way? What does it look like? Looks cold. Ready? Almost negative 400 degrees, negative 396 degrees Fahrenheit. That's pretty cold, even for you Northerners that came down here. So now we've got super hot, super cold, and they said over time, the core of Mercury would have frozen solid. And if you have a solid core, there's no magnetosphere. They found a magnetosphere. They said something recently must have hit it and blew off its outside edges. And that's why it's starting to slowly cool. And after a while, it will slowly lose its magnetosphere. Next slide. Next slide, please. And so they say it has a very, very light crust, small crust, because it must have been blown off, a bigger mantle, and a little bit of a core left. Next one. Now Venus. Now I had Sarai up here helping me with rotation. Now I'm going to need two of you. I need Sarai and I need another, and bring friend Sarai. Because we have to understand something, just like all those planets, if they had been made by evolution, they all should have the same type of magnetosphere, right? But just in case, if they were actually all created at the same time and in the same way, all right? Now, if I had a thing of M&Ms right now, let's pretend I had a whole thing of M&Ms. Can you show me how you would throw the M&Ms? You would throw them. Now, if you threw them this way, would they go that way? Are you sure? You're positive? Okay, so I need you to show me how you were rotating before. Go ahead. Mercury, Earth, keep going. Mercury, Earth, Mars, Jupiter, not Uranus, Neptune. Okay, stop. Now, what's your name?
Mackenzie.
Mackenzie, could you do me a favor? Could you rotate too? But I one more thing though. I need you to go the other way. Could you do that? Go ahead, go this way, and you go that way. Why is it 7 of our planets go in one direction and one, Venus, goes exactly the opposite direction? Thank you so much, ladies. Another thing that should happen if evolution was true is that if they all were going in the same direction and everything had the same tilt, they should all be spinning in the same direction. However, they believe that something
Big hit it.
Something big hit it. Hold on, it's not the last time you're going to hear that one. The moon. Now, I'm not supposed to talk about the Earth tonight. That's a different night. That's a different seminar. So we're going to talk about the moon, our closest neighbor. The moon is about the size, if you went from diameter one side to the other, it's about the size of the United States. So you could drive across it. All right. It would take you a few days. But the moon, next slide. What would happen, let me say, if you smush together chocolate and vanilla cake? Who could tell me what would happen? I'm going to see, get someone from back here now. What would happen if you smush together chocolate and vanilla cake onto a plate? What would you have?
Crumbs?
Crumbs. What kind of crumb?
Chocolate crumbs.
Chocolate crumbs? Is it just chocolate crumbs or is there anything else on there?
Chocolate and vanilla crumbs.
You would have chocolate and vanilla crumbs. Now, there was a theory for a long time that said that our moon was created when something big hit it and it was ejected out into space and it got caught in our gravitational well. However, there's a problem. They even have a name for this pretend moon called Theia. The problem is that the elements that are on the moon, when they went and got those moon rocks from 1969 and 1971, they came back with moon rocks. And it was exactly the same elements as the Earth. And they estimated up to 40% of those moon rocks should have been from an alternate source not found on the Earth. Where did the other rocks go? Are they hidden? We don't know. But for some reason, it was the exact same type of element, so it wasn't make sense. Then they came up with another theory. They had to go, uh-oh, if this isn't working, we can't believe in creation, so we have to come up with another theory. Different things must have hit it. And 20 different things, ready? 20 different planetesimals hitting at exactly the right angles at exactly the right times must have hit the Earth to if evolution was true. That to me sounds like a lot of intelligent design had to go into that one. So do you think if the sun and the Mercury and Venus and the moon as all been by chance, how do you think they got here? What do you think? I want a young person. If evolution says, if the sun and Mercury and Venus and the moon all say evolution doesn't work, then how'd it get here? You're not sure about that one yet? We're going to keep going then, because I want.
God made it.
All right. God had, because just like you told me, even if my pants are pink, my shoes are not red. If it's a part of it's not true, it's not true. Right? And we're going to show you tonight even more things that are not true. All right. Next one, please. Okay. Now, 4.5 billion years is a long time. All right. So the idea they have, why do they pick that number? They said it has to take so long. Why? Because it's so intricate. Everything is so perfectly done. It needs to take a long amount of time. However, there's a problem. Did you know that our moon is slowly wandering away? Did you know that? You did know that? Awesome. Our moon is ever so slightly and ever so slowly wandering away, ever so little bit. But we have something called tidal bulge. Now, for those gentlemen or ladies that were surfers or have any former surfers or current surfers in the group. Oh, I have a surfer. Okay. Yes. All right. I wonder if you're at Surf Skate Science. All right. So surfers in the group. You like the surf? You like the tide and the waves? The moon causes those waves. But the same action that causes those waves also ever so slightly as the moon is going, there is another action that's slowly pulling it away from us. Slowly pulling it away. Now, if we went back, let's say, 8,000 years ago, 6,000 to 8,000 years ago, that's fine. Only be about 750 yards closer. We're good there. However, if we went back 4.5 billion years, the Earth and the moon would be beyond kissing. If it's actually moving a tiny bit further away and you go backwards, it would have smushed into the Earth actually only 1.7 billion years ago. Wouldn't even take 4 billion years ago. So it's not possible that the moon really could be that old and in the same orbit. Next one. Ghost craters. Did you know they have ghost craters on the moon? All of a sudden, I've got like big wide expressions. There are volcanoes on the moon. There were these ghost craters that there was an early bombardment period where a lot of craters hit the moon and cracked part of the surface, and they have what they see is a ghost crater. Now, don't know if you can see it real well. You see the regular crater, but you also see some around the edges, not the best picture, but you see some edging over here as well. All right, and these edging here are part of the ghost craters. Now, why is that a big deal? Lunar geologists say that when the volcano happened, when something hit it, that the crust cracked and it had to take over 1 million years for the lava to come out. In your experience of volcanoes, Hawaii doesn't take that long. And Hawaii is always going a little bit. But even Hawaii doesn't take long for the lava to flow out once the crust of the Earth is cracked. When you crack a crust down to lava, lava flows out. It doesn't take 1 million years for the lava to go over an area. But they believe for these ghost craters to form, it had to have taken over 1 million years, and then new craters had to go right on top of it. That just doesn't make sense. Next one. Phobos and Deimos. These are 2 moons of Mars. Now, ready? I'm going to need two people. I'm going to get some people from the back here. I need the two young ladies right here. Or actually, one young lady, one gentleman. Come, one of you, one of each. Let's go. Phobos and Deimos. One of each. A gentleman, a young lady. Come. Actually, I probably need a third. Can I also, yeah, you come. Mhm. All right, sir. I need you here. I do, of course, on stage. Of course. And what's your name, sir?
Gage.
What is it?
Gage.
Gage. Excellent. I need two young ladies. What's your name?
Alethea.
Alethea, over here. And what's your name?
Sienna.
Excellent. Sienna, right over here. Okay. So we're going to make Alethea, you're going to be Phobos for a moment. Okay. Now, these two moons of Mars, only has two moons, by the way. They actually had a very weirdly amazing elliptical orbit. And I'm not going to go into the physics of it right now, but this is really cool. When you catch a ball, if I had a gentleman back there throwing me a ball here, it would not be coming in straight at me. It would come in curved, right? Okay. But when I caught it, it would also come in at an angle because I'm catching the ball. Guess what? They believe that Mars caught these two moons at exactly the straight, perfect curve, and all of a sudden it went right into orbit without the curve. Interesting that it's off that way. However, now, Alethea, you are going to be Phobos. You're going to be Deimos, okay? I've got two moons. Now, ready? One of them is slowly inching away from Mars. So I want you to slowly move this way, slowly move this way, slowly move this way, stop. You are going to slowly move toward this way, toward this way, toward this way, toward this way, stop. Now, I want you to get the idea. One moon is getting closer. One moon is getting further away. Now, only 6,000 years ago, we're good. Even 10,000 years ago, we're still good. However, if you went back 4 billion years ago, guess what? There is a thing called escape velocity. Escape velocity means at some point a rocket can go up in the air and not fall back down. Okay? Because it escapes Earth's gravity, is able to keep going and going and going. Well, guess what? If 4 billion years ago, she was moving away, moving away, moving away. If we went backwards in time, right? Move backwards in time, move backwards in time, move backwards in time, move backwards in time. She actually could have never escaped gravity. She actually would have passed a point where she would have actually crashed into Mars instead. And this beautiful young lady, say her name one time, Sienna, right?
Yes.
You are moving this way toward him now, but hold on. If we went way back in time, ready? Go this way, go this way. Hold on. 4 billion years ago, she wouldn't even be in the orbit. She never could have started orbiting Mars. So we have two moons that do not make sense. Thank you so much, ladies and gentlemen. Next slide. Nope, not going. Okay, ready? Oh, all right, we're going to go fast because I'm going to finish up real quick. Jupiter, I remember I said has a magnetosphere. It actually has heat from inside itself. Why? Jupiter is so far away, it can't get the same type of weather that we do here, right? The sun interacts with our atmosphere and we have weather. We're hoping for a front. We're hoping for clear skies. Lord, give us this clear skies soon, right? But Jupiter actually produces more of its own heat than the sun. However, it is starting to slow down, because it can only last so long. Internalized heat can only last so long from a planet because it's out there in the cold of space. Now, going back a few thousand years, okay, maybe even a million, but 4 billion years is too long. It would start to run out of too much heat to ever have those storms like the Great Red Spot. Next slide. Io is the most active volcanic body in the entire solar system. Imagine like one giant volcano. However, again, in the coldest space, it could not keep the volcanic activity for so long. This is any moon too. Go. Why does Uranus lay on its side? Remember how we had Soraya up here rotating in one direction. And then we had, I think, her sister here rotating in the other direction. Oh, Uranus is just tired. It's all the way on its side. So we have planets rotating in this direction, another planet. So we've got Mercury, Earth, Mars, Jupiter, Saturn, and all of a sudden Venus is backwards. Uranus is just totally catch God's sense of humor the first time. We get to Uranus and we realize it's literally 90 degrees over and just on its side, just sort of wobbling around the solar system. Okay, so they think, what happened to Venus to make it go backwards? What happened to Uranus to make it go on its side?
Something big hit it.
How many times can we use that as the excuse? One more, please. Neptune gives off 2.7 times the heat that it gets from the sun. In other words, it gets some heat, very, very, very little. It actually gives off more heat. This planet could float. However, there's a problem. Long term, it would run out of heat. Really, it's 4.5 billion years is a really long time. And it cannot sustain that type of heat output for that long. Next one. However, he, God, stretches out the heavens as a curtain and spreads them out as a tent to dwell in. You know, I studied this last year. I was taking a history of philosophy class, and I was fascinated that the early Greeks believed that the earth floated. Actually, it floated like in a pond, like in an ocean. And it makes sense. You see things and they float and they sort of bob around. I can see how people would think it's floating, but that's not what God said. It actually says in Job how he hung the heavens from nothing, which makes a lot of sense when you look at gravity. And you see there's no strings attached and there's no floating water. And it doesn't make sense if someone looked at Isaiah and said, you must be crazy. God stretches out the heavens. They used to think that it was all static. It was all the same until all of a sudden they found, ready? That the universe is expanding. God's stretching out his tent. Wow. All right, next one. I want you to know that, remember I told you I was going to come back to this verse that said, and he made the greater lights to rule the day and the lesser lights he ruled the night. And there's another part of that verse I didn't include. It's a last little piece of a phrase. And he made the stars also. I want you to see, though, if anything tonight, not only is man's explanation by chance impossible, but God's handiwork really, truly declares the glory of our God. Imagine that. And he made the stars also, like an afterthought. Like, you know what? This would show off my handiwork. And this is, by the way, that picture that I think that was the one that they expected to be on your paper. This is just one tiny image from it's called the Deep Hubble Scope. And they did what they pointed it in an area of total dark, just looked as black as could be. And they turned it on and looked at through this. And this is what they saw. These are not stars. These are galaxies. These are millions and millions of galaxies. And he made the stars also. Next slide. For the heavens declare the glory of God. The skies proclaim the work of his hands, not man's explanations. It is God and God alone who could create, who could design such a perfect and orderly solar system. Thank you.